All matter is composed of atoms, but atoms themselves also have structure. Atoms are made up of two distinct parts, a nucleus surrounded by electrons. The nucleus is found in the center of the atom and is composed of protons and neutrons. The protons in the nucleus have a charge of +1, and neutrons are uncharged. The nucleus is surrounded by a shell of electrons. Electrons have a charge of -1 that can balance the charge of protons. Atoms with the same number of protons as electrons, such as hydrogen and helium atoms, are electrically neutral. The number of protons is a characteristic of each element. Hydrogen has 1 proton, helium has 2 protons. Atoms of the same element may have different numbers of neutrons. When this occurs, the atoms are called isotopes of each other. Deuterium and tritium are isotopes of hydrogen, and they contain 1 and 2 neutrons respectively. Some isotopes are stable, others are radioactive. That is, they spontaneously break apart. In tritium, a neutron breaks apart, releasing an electron and leaving behind a proton. The resulting element is helium. The chemical properties of atoms are determined by how many electrons their outer electron shells need in order to be filled. If this outer shell is filled, the atom will be chemically stable. Two examples of such stable atoms are helium and neon. Helium's outer electron shell holds only 2 electrons, and so it's stable. Neon has 2 electrons in this first shell and an additional 8 electrons in the next shell. These 8 electrons completely fill this shell, so neon is stable as well. As atoms have more protons, they must also have more electrons to balance the charge. These electrons are in shells that all hold specified numbers of electrons. When they're filled, the atoms are stable. If they're not filled, then they must gain electrons by forming chemical bonds with other atoms. Atoms with an almost full outer shell, such as chlorine, can fill this shell by gaining an electron. This will leave the atom with a charge of -1 because the number of electrons exceeds the number of protons by 1. A charged atom is called an ion. Atoms with few electrons in the outermost shell, like sodium, can lose these electrons more easily to end up with a more stable empty shell. This leaves the atom with a charge of +1 because its number of protons exceeds its number of electrons by 1. Sodium and chloride are positive and negative ions, respectively, that are attracted to each other because of their opposite charges. They can form an ionic bond. Such compounds form extensive crystalline networks. This crystal is common table salt, sodium chloride, NaCl. Atoms can fill their outer shells by sharing electrons. This sharing is a form of chemical bonding called covalent bonding. Covalent bonds can occur between atoms of the same type, such as 2 hydrogen atoms or 2 oxygen atoms, or between atoms of different types, such as hydrogen and oxygen. Covalent bonds between atoms that are alike share electrons equally and are called nonpolar covalent bonds. For bonds between different atoms, the sharing of electrons depends on each atom's intrinsic affinity for electrons. The affinity of an atom for electrons is a characteristic of the atom. Bonds between atoms that differ in affinity for electrons are called polar covalent bonds. The term polarity refers to the fact that the electrons spend more time near the atom that has a greater affinity for electrons. In the example of water, the electrons spend more time near the oxygen atom, giving it a partial negative charge, and less time near the hydrogen atoms, giving them partial positive charges. Although a water molecule has partial charges, these charges balance, making the molecule electrically neutral. The polarity of water has far-reaching effects on biological systems.